Hello guys, welcome to my YouTube channel. I am Arthur Singharai, a second year BSc Physics student from Jadavpur University. This is my first YouTube video. If something goes wrong, just remember I am trying my best. Thank you.
Hello everyone, I am Anindo Vishwas, a second year physics undergraduate student at Jadavpur University. I was also involved in this AQI making project, and I have mainly worked in the soldering purpose of this project. So I hope you will like it. Thank you.
Hello, I am Pronoy, second year BSc Physics student at Jadavpur University. I am also involved in this project.
So this is our complete project setup. This is PMS3003 sensor, which is the main AQI sensor. This is MQ135, the gas sensor. This is DHT11, which measures temperature and humidity. This is ESP32, the main microcontroller of the system. This is OLED display, which shows value on the screen, and this is 9-volt battery, which is connected to the system. So after switch on, you can see the value on the screen. So after switch on, you can see those value on the screen. The temperature value is 34.20 degrees centigrade. The humidity is 67%. Gas value is 639. The PM1 concentration is 32 or 31. PM2.5 value is 50. PM10 is 64. And the main AQI, which is calculating on this database, is 83. So the status is satisfactory. So now I will introduce to all of you what is AQI and what is the working principle of each sensor in our circuit. The air quality index, or AQI, is a standard index used to measure and communicate the quality of the air we breathe. It converts the concentration of air pollutants into a single numerical value, making it easy to understand whether the air is clean or polluted. Lower AQI value indicate better air quality, while the higher values indicate increasing levels of pollution and greater health risk. The components which are used here are ESP32, MQ135, DHT11, PMS3003, OLED display, breadboard, jumping wires and power source. The softwares which are used here are Arduino IDE and Arduino IoT Cloud. So this is the AQI formula using which we are calculating the AQI value based on mainly PM2.5 sensor, where IP, the index for pollutant P, CP, the truncated concentration of pollutant P, BPHI, the concentration breakpoint that is greater than or equal to CP, BPLO, the concentration breakpoint that is less than or equal to CP, IHI, the AQI value corresponding to BPHI, and ILO, the AQI value corresponding to BPI. This is the Indian AQI system according to CPCB board. So if the daily AQI color is green and the values of index is 0 to 50 range, this indicates good air quality. The air is clean and there is little or no health risk. If the daily AQI color is yellow and the value of index is 51 to 100 range, so this represents moderate air quality. If the daily AQI color is orange, values of index is between 101 to 150 range, this means the air is unhealthy for sensitive groups such as children, the elderly, and the people with asthma or heart disease. If the daily AQI color is red and the values of index is between 151 to 200, so this indicates unhealthy air quality. If the daily AQI color is purple and the values of index is 2201 to 300, so this is very unhealthy. And if the daily AQI color is maroon and the values of index is 3001 and higher, so this is hazardous air quality and it is considered an emergency situation and people should avoid outdoor activities. So now I will explain the details about the sensors and components used in this project. This is MQ135 sensor. It is a gas sensor that detects harmful gases like carbon dioxide, ammonia, benzene, alcohol vapor, smoke in the surrounding air. Inside the sensor, there is a heating element and a sensitive material made of tin oxide. So when harmful gases come into contact with the material, its electrical resistance changes, and the microcontroller measures this change in resistance and converts it into an analog value representing the gas sensor. This is DHT11 sensor, which measures two environmental parameters like air temperature and relative humidity. For temperature measurement, the sensor uses an NTC thermistor whose resistance changes with temperature. And for humidity measurement, it uses a capacitive humidity sensor. The dielectric metal absorbs moisture from the air and changing its capacitance. The sensor converts this change into a relative humidity. This is PMS3003 sensor, our main AQI sensor. It is a laser-based particulate matter sensor manufactured by Plant Tower, and inside this sensor a small laser beam shines through the air. When dust particles pass through the laser, they scatter the light, and a photodetector measures the scattered light, and the sensor's internal processor estimates the number and size of the particles. This sensor provides measurements for PM1.0 particles smaller than 1 micrometer, PM2.5 particles smaller than 2.5 micrometer, and PM10 particles smaller than 10 micrometer. In this project, we mainly use the PM2.5 value because the Indian AQI system primarily uses PM2.5 to determine air quality. This is the OLED display. This is ESP32. This is Arduino. This is Arduino IoT Cloud. This is the main circuit diagram we used in our project. You can pause here and see the circuit diagram for your reference. So this is our mobile app live interface, and this is our desktop app interface, where we can find out in the AQI value measured by our circuit. So now we are talking about how AQI is calculated from PM2.5 value. So our PM2.5 concentration is 52 microgram per meter cube. So first we identify the AQI breakpoint. A PM2.5 value of 52 falls in 31 to 60 microcube per meter cube range. So according to our Indian AQI table, this corresponds to an AQI range 51 to 100. Now we use the AQI interpolation formula. This is the formula, and where CP is 52, BP HI is 60, BP LO is 31, IHI is 100, and ILO is 50. Substituting these values, our AQI is 86.4, and after rounding, the final AQI is 86. The display board in the circuit shows the following parameters, where you can see that AQI is 86. So we can conclude that the calculated value of AQI and experimentally obtained value of AQI exactly matches. We presented our work at the Scientific Innovation and Skill Development for Societal Advancement 2026 seminar organized by Innovation Skill Development Research Center, Department of Physics, Jadavpur University, and at Precision 2026 seminar organized by the Presidency University Physics Society. Here are some of the moments of us presenting our work at Jadavpur University and Presidency University. I would like to express my sincere gratitude to our guide, Professor Abirul Tamang sir, for his invaluable guidance, encouragement, and support throughout the development of this AQI system project. And also thanks to Professor Nobin Baron Manik sir for supporting and motivating us to do this project. I would also like to extend my appreciation to everyone who supported and encouraged us during this journey. Thank you.